Good day and welcome to Micrographics webinar, another one that we are giving out today. Today's webinar is covering Recap Pro. I'll be your host, Carl van Rooyen. I'm an application engineer with Micrographics. Today, as I mentioned, we'll be looking at Recap Pro. It's included with your PDM collection, your product design and manufacturing collection. And specifically, we're going to be looking at how can you use Recap Pro with Recap Photo and take that reality capture and use it within your other products within your collection. So I'll have a quick look at the agenda before we jump into our introduction. So we'll start off with an introduction onto what Recap Pro is and what Recap Photo is. And then we'll have a deeper look into Recap Pro, how it is used to manage point clouds. We'll look at Recap Photo. It is essentially a photogrammetry software. We'll talk about how that works. And then we will look at how we can use the results from these programs inside of Inventor and other products included in your collection. We'll then close off with a summary and Q&A. So onto the introduction. As mentioned, we've got Recap Pro and Recap Photo included in your product design and manufacturing collection. And so if you are designing using AutoCAD, Inventor, or Fusion 360 from within your collection, and you are designing anything that has to relate with, let's say, signage and building services, where you need to have as-built information of the building that you are designing for, or laying out facility planning within the building, you would be able to take advantage of Recap Pro and the point cloud management capabilities of that. And so having a look specifically on this page at Recap Pro, allowing you to be able to take point cloud data that comes from either LiDAR or laser scans, like the Faro, Leica, Topcon, many other brands out there, where you'd be able to use a laser scanner to scan either the exterior or interior of a building, and then use that to design whatever machinery, signage, services that you may be required to design to fit in, around, or on that specific building. And so the laser scan would allow you to work with as-built data for your designs. So if you're in that sort of industry, then this webinar is definitely something for you to have a look at. Then if you're into reverse engineering, if you have to take existing products, scan them in some way and reproduce them, then you could also use Recap Pro, use the direct point cloud as a comparison. I've done this in the past with some mining equipment for creating replacement, let's say, buckets or gates. And so taking the existing point cloud and modeling components over that existing point cloud. Alternatively, Recap Pro also does a point cloud to mesh conversion that does require tokens or credits. And so if you want to actually get some geometry out of it that you can work with, a mesh file, you would be able to convert point cloud to mesh. And we also have in Recap Photo the ability to convert photos to a mesh, basically an STL or OBJ type mesh. And that would be the Recap Photo side of it with the photogrammetry. So if you need to in any way reverse engineer anything, or maybe even survey areas where you don't have access to a laser scanner, there are various different options. Just to maybe look at the three images at the bottom. On the bottom left hand side, there is a statue that has been scanned in using a standard camera. Just lots of photos taken, and those photos uploaded to the Recap Photo service, which stitches them together into a 3D mesh. And the skate park on the right hand side is also the same. That skate park may have been surveyed using a drone, flying a grid, taking photos of that skate park from all different angles, and then those photos are stitched together to create that mesh file with the colors on it. In that case there, you could go in and design fencing around the edge of the grassed area. There might be extra ramps or rails that need to be designed for the existing skate park that could be designed over that mesh file. You might be even doing something like a miniature of the skate park, and you could use that mesh file to create a mold for the miniature, or to program machining for that. And then in the center, we've got a building, that white building, which is actually a point cloud with the RGB data from the scan itself. So we get the colors of the buildings, the ground, the grass, the plants growing on the building. So there we have that that scan there, which would be managed inside of Recap Pro. So, from an introduction perspective, if you're looking at designing anything that has to interface with, whether it's small objects that you want to include in your design, or even large objects like buildings or parks, you'd be able to take that, capture that reality, basically using reality capture through some form of scanning method, either laser or photogrammetry, and then using that inside your design software, whether it is Inventor, AutoCAD, or Fusion 360, to name a few. You'd be able to use Recap Pro or Photo to manage that data. So we'll go into an overview of Recap Pro and what Recap Pro is used for and how it works with the point cloud data. Essentially, Recap Pro is your management tool for your point cloud data. Essentially, you can take your raw scan data directly from your scanner. Obviously, there are supported formats. I think I've got that on the next slide. But you'll be able to take that raw scan data, bring it into Recap, have it all indexed and aligned correctly, so that if you've taken multiple scans from different points, Recap Pro can align those scans. It's essentially index those scans so that they are aligned with each other. And so you can take these large as-built scans of buildings or equipment and bring them in and view the entire scan set. And this, like I said, makes use of the raw scan data. So you load those files in, Recap manages them and stitches them together. This then allows you to isolate the required geometry. This is very important because the scans that are taken are going to include potentially a full 360-degree view from the scanning point. So in the example that we'll see today, there are multiple scans taken within a city center, but we may want to just isolate a single building. So we can see here on the right hand side, there's a single building there. We can see the two facades of the building. We may want to isolate that building and get rid of the rest of the mesh and work with only that building. So Recap Pro will allow you to isolate and either completely remove by deleting the other points, or creating what we call regions, where we can hide all the regions that we're not interested in and keep just the region we want. It also allows you to reduce the density. These scans can have tens of millions of points within them, and we may not need to have so many scan points. So we would be able to, what we call, decimate the scan to reduce the density, reduce the number of points, make it a little bit more lightweight for your computer to handle if you find that your computer is struggling to handle the large scan. So the process, if we're having a look at some of the basic steps within the process, you would import your raw scan files. You can see there's a list there of supported file formats. So anything from your Recap scans file type, RCS, to Faro, Leica, LiDAR, Topcon, Regal. There's a couple of different other options there as well. So various formats that are supported, where you can bring those raw files into Recap Pro. Those that scan data is then indexed and registered to align all the scans to a single coordinate system and to ensure that all the scans align with each other. And you can also identify or use physical targets within your scans. So you can physically place down an object or objects around your scanner to have them there to be able to set them as targets, or you can manually identify targets within the existing scan, maybe like a security camera or a group of geometry that is sort of unique across the various scans, and it can also use those targets. Decimation, I already mentioned. We can reduce the number of scan points. Maybe you have 50 million scan points and it's just a bit too much for your computer to handle. You could then reduce that down by reducing the density of the scans. A limit box is also quite a useful thing. You can use the limit box in Recap Pro to reduce the size, essentially cropping out information you don't need. We can actually see that on the right hand side here. That limit box around the scan, essentially like a bounding box, and you can then adjust your X, Y, and Z dimensions of that bounding box to reduce the size of the scan. That's a nice quick way to isolate out quite a lot of geometry, removing a lot, and then you can go in after that with a much finer tool to be able to select and delete geometry you don't need. Recap Pro also allows you to create scan regions. So scan regions allows you to essentially choose all the points that make up a building and then create a region that describes that building. So you can set the visibility for that region on so you can see the building, and then switch off the visibility for the other regions to hide the other regions. So you can isolate a specific building or a selection of points that you created. You'll see in our example here, we've got a couple of different regions that we will see in the scan. And regions are important because when we bring the scan into Inventor or into AutoCAD, we are able to set the region visibility for that scan file inside of the software that is being used. So you can have, if you do need to have the entire scan within your design, let's say you're using Inventor and you're doing an entire factory layout, you can have that entire factory scan inside of Inventor, but you can hide the regions you're not working with. If it's a motor vehicle assembly line, you may have the drivetrain assembly, you may have the chassis assembly line, various other sub-assembly lines. And you can hide those regions that are not being worked on to be able to work with a much smoother design process, or should I say just reduce the amount of resources required. So once you have gone through the process in Recap, the file is then saved as an RCP file. It's a Recap project file, and that file can be attached to an AutoCAD file, Inventor, Navisworks, etc. There are a couple of different packages that can bring that RCP file into and then be displayed where you can design around that point cloud. So this will bring us into our first demo. So I'm going to go ahead over here into Recap. Now, to save time, I've taken a example data set from Autodesk. So we won't be going through the import of the scan data. However, that would be done by creating a new project when you launch Autodesk, when you launch Recap, and you would choose to create a new project and you select your scan files and you would go through that process. That process can take quite a while depending on the size of the scans. You can see this is quite a large scan. So what I'm going to do here is concentrate more on isolating the geometry that you need to work with, the part of the point cloud that you need to work with. And in this case, I want to isolate this white building here on the corner. So there are a couple of different tools which we can use for this. You'll see in Recap down the left hand side, we have a menu here with a couple of different options with regards to, let's say, the color. We can, code this according to elevation or intensity. couple of different color codes here that we can set up. Classification as well, something I haven't mentioned, but we can classify buildings, classify ground. This would be more for, let's say, civil and infrastructure usage. Classifications don't come through into, let's say, Inventor software. So here I'm just going to change it back to RGB, which shows the colors from the scan. And on the bottom right hand side here we have the essentially your browser for the project, and this shows us our scan regions. So here we've got various scan regions that are already created. You'll see I have a buildings scan region. There's some other regions for existing demos or existing buildings. And essentially what you can do here is you can set the visibility on and off of these regions. So let's first create a region. I want to create a parking lot region here for this parking lot. Maybe we need to design a cover for the parking lot. They want to put shade cloth up or a solid roof structure up, maybe for a solar installation or something of the like. So at the bottom we can go grab, let's say, just the fence tool to be able to identify the area that's going to be covered. So let's say we're going to do something like this here, around to the front of the building. And I'm going to press enter on the keyboard. That creates a selection. And then at the bottom, you'll see that we have a region option now. We can choose to add new region. So I'm going to call this one parking lot, and that region is then created. So we now have a parking lot region. So if we switch off all unassigned points, we'll see points that are assigned to regions. We've got buildings there. We can hide those. We've got some existing buildings. There's the parking lot, and we also have regions where there is all the poles and wires. So we could even hide those as well. So we're left with just the parking lot region. So this is one way of keeping all of the scan data, but being able to isolate a specific area of the scan data. Alternatively, we can use a limit box. And the limit box allows you to pick a surface and adjust, and basically pick a surface of that bounding box and adjust the bounding box. And so here, if I go, we don't need all the height of the building potentially for looking at the parking lot, but maybe we need to see the trees. So I'll limit the height to just above the trees, maybe just above the building that is next to the parking lot, which would be about there. And then we don't need to see all the buildings across the road. So we can take this side of the bounding box and we can bring that into roughly the middle of the road. And so you would go and you would basically grab all the different sides of the box and reduce the mesh down to show only the area of interest. So let's say we go to there. We can then confirm, and we then have our reduced limit box. Now, one thing with this is the rest of the geometry is still there. The rest of the point cloud is still available. It's not being deleted. And if we want to have this come through into our other software, I suggest then creating a region from this. So that limit box allows you to essentially crop out the rest of the, or hide the rest of the points. You can then select the visible points and create a region from that. So here, let's say I unassign the parking lot because there's some of the parking lot region in there, and I'll assign this again, and I'll just call this large parking lot. And so now we have a new region for that large parking lot. We can also run or create classifications. This is a process that takes quite some time to scan through the entire point cloud and do. So what I'm going to do here is I'm going to go to the limit box and reset the limit box so we can see everything. and I'll go through some classifications here. Once again, we've got, in this case, we've got some objects that are classified as ground, and I've got a classification here as buildings. And we can switch off, let's say, those classifications, and we see all the other points that are not classified at the moment. So we could go and choose manually classify, or there are essentially the ground classification is an automatic process to classify the ground that allows you to find at least all of the flat ground points, and then from there you can hide that and select regions and classify those. Once again, the classification is more for use in the civil realm, where regions is what we would use to show and hide features or parts of the point cloud within programs like, let's say, just AutoCAD or Inventor. So once you are done with, let's say, isolating out a specific building, let's say this region here, I'm going to hide that. You can, if you want to reduce the point cloud down, you can highlight the rest of the points and press delete to delete those points. That will reduce the size of the point cloud down to only the data that you need for your specific project. So in this case here, we'll have just this area. Even this here, we could break it down into different regions because we have the 3 buildings here, maybe a region for each building. But the rest of that data might not be needed for the project. From here, you would then save the file, and that would be saved as a recap project file, which can then be added into your software that supports that RCP file format. So that is it for the recap demo. We'll move on to the recap photo side of things. Now, recap photo uses photos. It's in its name, so it uses photos to stitch together the photos using a process called photogrammetry, where it will then generate a 3D model. Now, the photogrammetry portion, or that process of photogrammetry, can be used to create a 3D mesh file, typically an STL file, of objects. They could be small objects, sort of the size of a cell phone, potentially even smaller, all the way up to large scale buildings, construction sites. And the size of the object is going to kind of determine how you should take the photos in a way. So if you're doing small objects, you can use any sort of handheld camera just without autofocus. You want to have a fixed focus point essentially to have better results, and you would take the photos. I typically just use a cell phone, take a whole lot of pictures of an object and then upload it to the service. I've done this for small objects like water pumps, leaf blowers, all the way up to scanning my swimming pool, my backyard, to be able to plan for, let's say, doing an extension or a deck or any building work. If you're getting really large, like the scan we see on the bottom left side there, or at the bottom of the screen, then you can go over to using a drone, and you can have a drone fly over and take a grid of photos, and high shots, low shots, as many photos as possible. This is a cloud service as well, so once you import all of your photos into the software, they are then uploaded to the cloud, and a cloud processor or server stitches them together. You then get a mesh that is then sent back down to the software. Within the software, you can then edit that mesh. We'll go through a demo with some of the editing options that we have within the mesh. We'll open up the statue on the right, play around with that a little bit, show you what options are available. And that mesh can then be exported in various formats to then be used in other software. You're not limited to Autodesk software in that regard. you can go into any other software, you have that mesh, and you can then use that mesh, typically an STL file or an OBJ, could even be exported as a quad mesh, so a four-sided mesh. I know that's quite nice for Fusion, to be able to convert that quad mesh in Fusion into T-spline surfaces if you need to make any changes. Maybe you want to modify the statue and make it look different in some way. And that goes back to the reverse engineering side of it, where you can take that scan, essentially the scan, all the photos of an object, and have it converted back into a workable mesh file. So as I mentioned, the process for this, you would use a standard camera for small objects. On the right hand side here, you can see I've taken a whole lot of photos of a Makita leaf blower. There are a couple of things wrong with those photos, and I'll mention it now. But essentially you take as many photos as possible from, let's say, a low, medium, and then a high position, so you can get all the different angles on that object. But you do want to keep lighting as uniform as possible. You'll see there's quite a big shadow underneath that leaf blower, which may cause issues with the scan. And I think at one point some of those pictures between the leaf blower and the light source, so the color, the lighting on the leaf blower is a lot duller, it's more in the shadow, so that may cause issues with that scan. So you want to keep the lighting as uniform as possible, and it also doesn't work well with reflective or glossy surfaces. So if you do have any reflective or glossy surfaces, you would want to use some sort of a spray. I've seen guys use penetrating sprays that are used for weld inspection. Basically, you just spray it on, give it a matte coat over the object that you're trying to spray. Another thing is also using a little bit of a trick I've seen is using multicolored sticky notes and pasting them either over your object or on the ground around your object, and that essentially just gives points for the software to be able to tie together from photo to photo. So if it sees a green sticky note in one photo and a green sticky note in the other photo, it knows that potentially those two green sticky notes should tie up to the same three-dimensional point in space. And so in Recap, you'd create the Recap project, you would upload all of your files, your photos. It will then create the mesh and send it back to you. You would then be able to edit and export the mesh. So it's demo time here. What I'm going to do quickly is just close Recap, just to free up a little bit of resources. And let's go into, so close Recap Pro. I'm going to go into Recap Photo. So if I go back here on my dashboard, unfortunately I don't have that leaf blower project, but I do have some demo projects here. There is that laughing Buddha statue, which I have open. And this is essentially the result of a whole lot of photos. We can see we can get quite good detail on that model. So this is a scan, and it brings in all of the color detail from the photos as well. You can adjust the visualization. So if I go here solid with the wireframe, we can also see the density of the wireframe. One important thing with this is that the software has no idea on scale. It doesn't know how big or small this statue is. And so it's always a good idea when you are scanning an object is to place a ruler or something of a known size within the within the view of the picture, the cameras, and that can be used to then scale the object. So we have a ruler here, 300mm or 12-inch long ruler, and we can use that to then scale this. I've had pretty good results. If you're thinking about sort of the scale of scanning a swimming pool and the surrounding area around a swimming pool, I've scaled using a step that was about 1.5 meters, 1.6 meters wide. So scaled that to size, and on the opposite side of the swimming pool, dimensions on that side of the pool were maybe within a couple of millimeters. And so the scaling is quite reliable on this. So if you're doing smaller objects, your scaling or your tolerance will obviously be a lot better. So on the left hand side, we have our editing tools. We've got some model settings. We can transform the model if we want to rotate it at all, or move it in any direction. So we can see here we are able to actually grab and rotate this model to align it with a maybe it's not quite flat and we want to have it aligned with our ground plane. So if I look at it from the right here, it is leaning forward slightly. We could rotate that round to get it into a more upright orientation. But just want to go here, set scale in units, just to show how that works. So units in millimeters, I'll use the millimeter side of the ruler. And what we can do is we can either scale by percentage, so we could take a measurement and then work out the percentage difference, or we can scale by value. And so what I'm going to do here is, as best as I can, I'm going to pick where 0 is on the ruler, and I'll pick where 300 millimeters or 30 centimeters would be, and I'm going to put in the distance here. We can see it's currently 12.857. So scaled too small. I'm going to make that 300 millimeters between those 2 points. We'll set it, and the statue is then scaled up. We should then be able to, let's double check out quickly, analyze and measure distance, and we can then measure from one side of the ruler to the other, and we get that roughly 300. Obviously the points that I clicked on are going to be slightly different, but we're getting that 300 millimeter distance there. We can also edit this. We can slice and fill, which allows us essentially to remove some geometry. So once we've scaled this, we might not need the wooden deck and the ruler. Maybe we just want the statue, and so we can take this slice and fill and can then just transform this downwards. Let's get this I'm going to transform the plane here, and I'm going to move that plane downwards. Let's have a look, see if I can get it far enough down. And that looks good there. There is some extra mesh this side. We could then go back in and remove that. Just want to get a good bottom there. I think that looks good. We'll apply that. You can also choose to fill the bottom or not fill the bottom. So if I was to, let's say, 3D print this, I would want to fill the bottom so that it closes off that part. Oh, great. And the software just crashed. That's the joys of doing live demos. Let me just quickly launch that again. At least it's not too much of an issue. So let's go ahead here quickly and load that model up. Something is so happy with the software. Just give me a second here. It seems like the pan and zoom or the orbit option is stuck. Okay, let's try that again. Yeah, there we go. So we'll quickly do the selection here. $300, and we'll do the quick slice and fill. In this case, I'm going to do a no fill. I'm assuming the scan section on the right hand side there caused problems. There we go. And so what we'll do now is I'm going to go ahead here and select the box, select that region, and just delete on the keyboard to delete it. And so now I have the rest of that scan. So we have a couple of different options. We've got sort of very standard mesh editing tools, slice and fill, things like surface tools to allow for smoothing. We can smooth over or sculpt if we wanted to make modifications to this. If anyone's familiar with Mesh Mixer, it's got a couple of those similar tools. I'm not going to go and mess around with this mesh too much. Just want to do some basic things. Now, this could be an engineering component with hard edges, and you just want to be able to have that mesh to be able to either machine a copy or bring that into software, especially Fusion nowadays, Fusion 360. It's got some very good mesh options, especially if you have the design extension, the part design extension. You would be able to then convert that organic mesh into a solid. And so from a reverse engineering point of view, that is very useful. I'm just going to use the fill holes option here, and I'm going to grab the bottom boundary, and I'm going to add a flat cap to the bottom of this model. Just thinking about it. There we go. And so that just makes it watertight. That would then allow for it to be converted into a solid, let's say in Fusion 360. Or if you bring it into a slicing software and you want to print this out of from a 3D printer, then at least you have a watertight mesh. We do have some retopologizing options. Basically, we can retriangulate. If I just change this back into wireframe mode, you'll see that the density of the mesh changes. So we can retriangulate required sections, we can subdivide so we can create more triangles, and we can also decimate the mesh, essentially reduce the amount of triangles, reduce the mesh down, because we can see there's quite a lot of fine detail on this. That obviously does reduce the quality of the scan as well. Couple of analyze options as well. We can detect and fix any issues on the model. So we choose to detect issues, and it will go and see if there are any problems. So here it's come up with a intersection option here, or intersection issue, where the mesh is maybe self-intersecting, and that's actually around the bottom base that was added. And so we can remove all, we can preview all the intersections and maybe go and fix all of those problems. I'm not going to go through that, that will take a little bit of time. We can get a mesh report. We can also compare two models. So we might have a scan of a different, let's say in this case, statue. You might be doing a production run. You've taken two scans and you want to compare them to see if there's any, let's say, wear and tear in the mold, and to make sure that the production is consistent. And lastly, we can export. We can export just an image, video, or export model. And this is the important one. We can export the model and we can choose a format. So we've got OBJ, OBJ quads. Quads is a nice way to export if you want to then bring it into Fusion 360 and then convert this mesh into your T-spline surfaces within Fusion 360. We've got a couple of different options there as well, STL, PLY, PTS. So you would select your option if you want. You can also change coordinate to set Y as your up, and you can also then once again decimate the mesh, so you can reduce the mesh size. We can see currently about 200,000 faces. I know Fusion 360 typically moans when something has more than 10,000 faces. So you're going to have performance increase or performance issues. So you would choose, okay, let's decimate to a certain point. I typically prefer to retopologize first, use the decimate here first, because you'll be able to know what your outcome will look like. But if you don't want to modify this mesh, you can export and decimate the exported model. And then that export, I'm going to go ahead here, export, let's do an OBJ. I'm going to do, just so we see, I'm going to decimate this down 50%. Textures, we're going to rebake textures, so essentially the color is maintained on the part, and I'm going to export this out. And folder there, let's just do that. And we'll have a look at how this will come into, let's say I'll use Fusion 360 as an example for this one. So while that model exports, I'm going to jump back into the presentation. We've had a look at Recap Pro to handle the point cloud data. We've had a look here at Recap Photo to see what the result of that, what the result of a set of images would look like, the result of the scan, and what we can do with that scan. And as I mentioned, in this case I'm using a statue, but it could be an engineering component. Couple of work case cases that I've seen this used for could be the production of stamped steel components, let's say large body panels for vehicles, maybe windshields, formed windshields or glass, to be able to scan and then quality check the process, maybe first off runs, see if there's any modification that's required in the molds or the process of the mold. We spoke earlier about using the point cloud for doing facility layout. If you had a drone operator come in and they could fly the drone around your facility, or you take a camera and take photos of your facility, you would then be able to use that and get a mesh model of your facility. That would be, I think, quite a bit heavier potentially on the PC, but it is a possibility. Just to show you here, what I'm going to do is open up that skate park so you can get an idea on the size of that and performance. I'm working on just a workstation laptop, and so here we've got sort of a scan here. Let me go into the retopologize. We've got 2.5 million faces here in this scan. Obviously now that would scale, so the geometry just scales up. The face count remains the same, but if we had to go and measure something and scale this up, we still have 2.5 million triangles within this scan. And I mean, we can go down all the way down to the various portions of the skate park. There might be some weird anomalies, but we could go in with the edit tools and flatten those anomalies out. If I was a contractor that needed to create a fence to fence off this grass area around the edge, this would be great for me to be able to design the runs of the fence, be able to give a rendering of what that fence would look like, and be able to have that visual look at it and the design assistance of being able to have that exact perimeter to create a ballast railing or a fence for that grassed area. And so this scan would have been done with a drone flying a grid pattern, taking photos of the skate park. Yeah, let me close that down. We're going to get back to the presentation. And so we're at the point here in the presentation where we are looking at use inside of Inventor and other products. So as mentioned, we would get the point cloud from Recap Pro. We can attach that point cloud from Recap into Inventor, AutoCAD, or Navisworks. Now I'm going to go specifically into Inventor. It's the product that I'm more comfortable with, and we'll have a look in there just to see how that comes through and what we can do with it. If we have the time, I can also open up AutoCAD and throw it into AutoCAD. The mesh files that come from Recap Pro, where we do the point cloud to mesh, or from Recap Photo, we can import that mesh file into your design program, like I said, of your choice. It's a generic STL file format or OBJ file format, and then you model as required from there. So jumping straight back into a demo, let me actually get the AutoCAD out the way. I've got a file open here, just a blank template, and under the insert option we can attach, and the file format we can go down, we'll see there is the Autodesk point cloud option, and we can grab then the point cloud that we require. So I've got here this Brownsville buildings, that is the point cloud that I had open earlier. As per any normal attachment that you are adding into AutoCAD, you get the attach sort of dialog box where you can specify things like your scale, rotation. I'm just going to hit OK here, leave everything default, and the point cloud comes in. It does take some time to load depending on performance of your computer, size of the point cloud, but there we have that point cloud. Now if I select the point cloud, we then get a point cloud tab with various options. We can change the scan colors. We can go to object color, normal, so it shows the normals of the scan, intensity, so intensity of data points within the scan. I'm going to go scan colors, so it's the RGB. And just one thing to really look at here is cropping. We can, within AutoCAD now, crop this as well. So we have various cropping options. So we don't have to crop it within Recap, but managing it within Recap does allow you then in AutoCAD to go to the point cloud manager, and you'll see here we have regions and unassigned points. So we can go ahead and we can choose to not display the specific point. So if I go existing to remain, poles and wires, existing to demo, so they're looking at, in this case, existing to demo and existing to remain, buildings that are being demolished and buildings that should remain. It's a nice easy way in this case to show contractor this is what you're doing. But for our case, let's say we're a signage company, we have to do some signage on the side of the building. We're able to leave just those buildings within the scan. So you can use that point cloud manager to hide the regions that you don't need. You might be doing multiple project work on multiple buildings in the same area, and so you could hide and show the various buildings that you're working with. So in AutoCAD, you've got that basic management there, point cloud manager. And because you are working with that RCP file, you can always go back into Recap, make changes in Recap, and that will update in your AutoCAD. You'll be able to refresh that file and continue working with it in AutoCAD. No need to delete and re-import, reposition that file. Yeah, so that's quite basic here inside of AutoCAD. There are various options with regards to the point cloud management within AutoCAD. I'm going to go ahead and close that down and go now over into Inventor. And in Inventor, the nice thing is that you can create a part or an assembly, and you can insert a point cloud into either. So you can have a part with your point cloud in it. Let's say you're doing top-down modeling, you want to create a skeleton part or a reference component for your skeletal modeling, top-down modeling. You can create a standard part, put your point cloud in there, put in your reference geometry in that, and then from there derive out and create an assembly. Or you can create an assembly. Let's say you're doing facility layout, you create your assembly, you place in your point cloud in the assembly, and then you place in your equipment and position it relative to the point cloud. The various options available to you here. I'm going to go to standard IPT, standard part file, And within that part file, we'll go to manage, and you'll see there's a point cloud panel here we can attach. So I'm going to go ahead and attach the Brownsville buildings, same file that we brought into AutoCAD, and it'll come in attached to the cursor. Just simply click anywhere on the screen, and you will then get the options, much like in AutoCAD, to insert at a specific offset or at the origin. And you can also rotate angles as needed. There's the ability to adjust density. So 10 is bring in all the points, whereas in, let's say you put in a 5, it'll bring in only half the points into the design here. And max allowed points, we've got, what's that, 10 million points, and scale. So I'll click OK, bring it in as is, pretty much default settings. And that will then load that point cloud. Now, much like within AutoCAD, we do have an option here, it's called Navigator. When we select Navigator, that opens up and shows you the regions within the scan. So once again, we can switch off the regions that we don't need, and we are then left with the region that we want to use. Okay, so let's just hit OK there, get this. It seems like my space mouse is bugging out there a little bit, and it's just taking a little bit of time to come in and load. At this point, I might decide, okay, hold on, it's running a little bit too slow, so we can always go back to the point cloud in the browser, and if I edit attach data, we can then say, okay, well, let's bring in only half the points. And so that will reduce the density of that scan. Yeah, that might not be a good idea. Can't really see what's going on there now with the scan. So that's not going to work for this work case. So let's go back in, set that back up to 10. Okay, and then from here we've got the ability to create a work point attached to a point in the cloud, alternatively a cloud plane, which will create a work plane that matches the sort of an average plane of where those points are. So here on the side of the building, if I wanted to do some signage, I'll be able to select that plane or create that work plane on the side of the building, and from there, you know, start the standard process. So I'll start a sketch, and we'll be able to start to sketch. Now, once again, if you're doing facility layout, factory planning, then you know, you would be looking in a plan view and setting your machinery where it needs to be. The scan would be of the internals of the building. You'd also be able to then see, does your machinery clash with any rafters, any columns, are there any services within the building like water, electricity, pneumatics, ducting that your machinery is clashing with. In this case, I'm taking a look at, let's say, signage, and we want to create a big billboard on the side of the building. Maybe the client wants something that's 10 meters by 5 meters. And we can see, okay, if we're doing that on this building, you know, we're going to be covering at least one of the windows. Maybe we can position it somewhere where it's not going to impact too much else on that building. I'm just going to do a very basic just extrusion here on the side of this. Let's say that stands out. Maybe it's a frame structure that stands out 1/2 meter to give that window a bit of clearance. And so you would go through your standard design process here now, but you have that in this case, the building in the background to be able to reference info. So we could position, we could create a sketch that represents the side elevation of the building. Once you've got that information, you can always set the visibility of the scan off so that you can then rotate and work with the model a lot smoother as well. So sort of process that I typically would go through for something like this is in that sketch on that plane and sketch out the profile, the side view of that building, and then hide the scan, maybe include the windows in it, hide the scan so we'd then be able to reference the side of the building. If you were reverse engineering, maybe there was a damaged column and you needed to replace the column, you would be able to come in here to the scan data. I would then say isolate the column as a region, and you would then be able to model around that point cloud and use the point cloud as reference. You've got that circular area there. You could create 3 points. Nice thing about the ability to be able to put cloud points in is you could maybe box crop or crop this down so you've got a flush cut through the top of the pillar, and you could place down 3 points around the top of the column, create a work plane, you can get a circle through those 3 points. So you'd be able to then get the diameter of the column and continue designing from there. So various different options available to you within Inventor and let's say AutoCAD, the various products that you can bring this data into. Once again, you could render this out. You put an image on the billboard, the marketing material on the billboard, and you could render this out and say to the client, okay, this is what it is going to look like once it is finished. And then city council might need to get involved, and or municipality gets involved and has to sign it off as well. So we've got those available options within the software. Opens it up for the various different workflows as well. Okay, we're getting close to the end of the hour, but I do want to just look at that last one, Fusion 360. If I go back here, just go into, actually, I'm just going to open it. So within Fusion, what we would do here is insert mesh. And I'm going to grab that from my PC. And during that mesh insertion, I would then be able to choose what the units were. So we were working with this in millimeters. We can set the centering, or we can move it to ground so we can get this grounded on 0 and so on. So we can put in a couple of different options. We can translate it. Once we hit OK, we then have that mesh inside of Fusion. So this was an STL file that was brought in. We can also go insert mesh, and I can go here to OBJ, and let me see if I can find where I saved that OBJ. There's the OBJ. And we can do the same thing. There's the actual scaled, sorry, there's the scaled version. So we're going to delete the first one. And so there we have that file brought in. That's the OBJ file. And we could then continue working from there. As I mentioned, Fusion has some very nice mesh modeling options. We can repair the mesh. A typical workflow for something like this would be to repair the mesh, potentially generate face groups. But if you do have the part design extension, you would be able to convert the mesh and use the organic option. And so we have a couple of different options here. I'm not going to hit OK here on this. It's going to lock up my PC for some time as it does that conversion. But we would be able to potentially convert this into a solid to continue working with it, or alternatively using the mesh commands inside of Fusion to be able to play around, modify the mesh, clean it up. Fusion can create toolpaths directly from the mesh as well, so we could machine directly from this mesh, or go into the manufacturing environment and do additive and print from this as well. So with that being said, I'm just going to head back into the presentation, and we'll quickly close off with a summary here. So Recap Pro and Recap Photo essentially fall under reality capture sort of software. They're taking in reality as built conditions and allowing you to then bring them into your design. So if you work within any design sphere that requires you to include as built, as manufactured information within your design, these two tools are critical. They'll help you out with your design, managing point clouds for large scans, or being able to create STL files for assisting in your design process. So these two Recap products, Pro and Photo, are very useful for being able to bring reality into your design and continue working with it and use it as reference for your design. So as I got there on the second point, design around the as-built conditions, whether it's an as-built or an as-manufactured component, maybe you're doing quality testing or you're reverse engineering. That's my third point, you're reverse engineering something. Or you need to check manufacturing or build accuracy. You want to compare that scan to your original model. You'd be able to do that as well. So that'll bring me to the end. I've run a few minutes over, but I do apologize for that. Got through all of this, looking at the various options. So what I'm going to do is I'm going to hand over to Q&A, just to see if there are any questions. I haven't seen anything come through on the live chat. So what I'll do is we will wait and just give a few minutes to see if anything comes through, any questions. Actually checking, I see we don't have any participants on the webinar at the moment, so we won't have any questions coming through. But once again, my name is Carl van Rooyen, application engineer with Micrographics. My email is up on screen, so if you do have any questions, feel free to contact me on my email address. Alternatively, you can contact Micrographics offices, and they could forward you to the correct person to help you with your query. So once again, thank you for your attendance and for watching the webinar if you got this far. I would like to ask if you would like and subscribe if you did enjoy the webinar, if you thought it was useful and you're looking for any more sort of videos that are similar to this or cover topics within the manufacturing or architectural environment. We do have quite a few more webinar style videos as well as short videos on our YouTube page. So once again, thank you, and hope you have a good day. Cheers.